Lattice energy. Once the gaseous ions are formed, the ions of opposite charges come close together and pack up three-dimensionally in a definite geometric pattern to form ionic crystal. This process is accompanied with the release of energy referred to as lattice energy. Thus, lattice energy is defined as the amount of energy released when 1 mole of ionic solid is formed by the close packing of gaseous ions. The magnitude of lattice energy depends upon the following factors. Size of the ions. Smaller the size of ions, lesser is the internuclear distance and greater will be the interionic attraction. Hence, larger will be the magnitude of lattice energy. Charge on the ions. Larger the magnitude of charge on the ions, greater will be the attractive force and higher is the value of lattice energy.
Hess's law and Born-Haber cycle. What is Hess's law?
And the definition of Hess's law states that the heat involved in chemical reaction is independent at the routes by which the chemical change occur, and its equation is delta H reaction equal to delta H product minus delta H reactant. And Hess's law consists of two, that is algebraic method and energy cycle method.
So this is how algebraic method is done. In order to do the energy cycle method, first you need to look at the information given. Then write down the equation that you want to have. Look at the equation and write down another equation that do the formation of the molecules that you want. Born-Haber cycle. The Born-Haber cycle is used to calculate the lattice energies of ionic particles.
For example, how to calculate the lattice energy of NaCl? We must include delta H formation of NaCl, delta H atomization of NaNCl, delta H ionization of Na, and delta H electroaffinity of Cl.
Born-Haber cycle. In this video, I am taking sodium chloride, that's NaCl, as an example for explaining this reaction or this mechanism. So let's see the overall reaction taking place in Born-Haber cycle. Sodium adds with the chlorine atom and forms sodium chloride, liberating some energy. This simple reaction takes place through 5 steps, what we can call as Born-Haber cycle. So the first step is sublimation of Na in solid into Na in gas. So what is sublimation? Sublimation is a process of converting the substance in solid into a substance in gas without actually touching the intermediate states. So sodium taken in solid with the help of some energy, that is sublimation energy, can be converted into sodium gas. So this step is called sublimation of sodium solid into sodium gas. This is the first and foremost step. And the second step is half Cl2 molecule is taken and dissociation energy is given to it, forming chlorine gas. This is the second step, which involves dissociation energy. Step 3. The sodium gas which is formed in the step 1 is given ionization energy, forming ions, that is Na plus ion, liberating electrons. And the step 4 is the chlorine gas which is formed in the step 2 is given an electron from step 3 and it is formed into chloride ion, that is Cl- with liberation of some energy due to electron affinity. And the final step is sodium cation, that is Na plus gas, and chloride anion, that is Cl- gas, combines to form NaCl while liberating some energy, that is energy of formation. So these 5 steps constitutes the Born-Haber cycle. These can also be depicted as this. And finally, we can calculate the lattice energy represented by U, that is the amount of energy released when 1 mole of sodium chloride is formed. So that is the significance of this Born-Haber cycle. So this was a simple way of explaining Born-Haber cycle, taking NaCl as an example.